In this video, I will address how to graph an ellipse. Let's look at the first example. Now, the standard form equation of an ellipse takes on these two forms, similar to a circle that we've learned earlier. Since we only have x squared and y squared in the numerator, the center must be 0, 0. The major axis. So, which way does this ellipse go longer, left, right, or up or down? Well, since the 25 is the bigger number, then that's going to indicate that our major axis is going to be vertical. So I'm going to just kind of sketch it longer vertically, and it's going to go in the vertical direction. Okay, so I'm going to focus more on the second version of the standard form equation. So we have b squared and a squared in the denominator. So therefore a is the square root of that 25, so that's 5. The 4 is b squared, so b is the square root of 4, which is 2. Okay, let's figure out c and the foci in a little bit. So the center is 0, 0. According to my little checklist, I know it's going to go longer up and down. So I'm going to go up 5 and down 5. And then I'm going to go left and right too. Okay, and that's enough, these 4 major points, to sketch a nice looking ellipse. So you're going to do your best, try to make it look curvy. Sometimes I kind of think like a football, so that way it's not too pointy at the ends. So a nice little curved ellipse like so. Okay, the next thing we need are the foci. So to solve for the foci, we're going to use that formula in the previous video, which was c squared equals a squared minus b squared. Okay, so c squared, the 25 was a squared, so we get 25 minus 4, so c squared is 21, so c is the square root of 21. And if you were to approximate that, you'd get about 4.58. So we're going to label that point on here. So from the center, now we're going to go up and down 4.58. That should make sense because that's the way the ellipse is elongated vertically. So up 4.5. So there and there are where the foci are located. Okay, so the coordinates of that are, we have, let's see, x is 0, and we went plus or minus 4.58. So you can shortcut writing the 2 points like this since they're almost the same. Okay, second example. Okay, looking at this, let's start with the center. So the center is 2, 5. We find the center basically the same way we would do for a circle. Okay, the major axis, which way is it going to be longer? Well, the 49 is the bigger number. So that's, and remember, the bigger number is the a value. So that's a squared. So a must be 7. And the b must be 2. So the major axis in this case is horizontal. So we expect our ellipse to go longer left and right. Let's go ahead and sketch it, and then we'll deal with the foci in a little bit. Okay, so our center is at 2, 5. We go left and right 7 units. We go up and down 2 units. Okay, and then you've got your 4 endpoints of the major and minor axis. So we're going to draw our best elongated ellipse. Okay. I try not to make it kind of pointed at the ends. You want to make it look rounded as best you can. Okay, so next we're going to solve for the foci, and that's using the formula. C squared is a squared minus b squared. So c squared equals 49 minus 4. So c squared is 45. So c is the square root of 45, which is about 6.71. We could have simplified that radical. I think that was going to be 3 root 5, but I'm more concerned right now about the approximate answer. So the foci. So I have to go left and right. So I'm going to take the center, which was 2, 5, and I'm going to add 6.75 to the x values to go left and right. So I'm going to take 2, I'm going to add and subtract 6.71 to the x values. You could also estimate where that's going to go. So I'm going to go all the way over here. It's going to be pretty close to the endpoints. It's a pretty skinny looking ellipse. So the further and further you stretch it, the closer and closer the foci get to the endpoints. So the coordinates you're going to have are going to be 8.71, comma 5. That seems about right. And negative 4.71, comma 5. Okay, I'm going to do one more example with you guys. Letter C. Okay, scanning it, we look at it, I'm like, okay, so the center is going to be 0, 0. And once again, I'm comparing that to the standard form equation in our previous notes. Okay, the major axis. Well, who's got the bigger number? And that are the x values. So 100 must be the a squared, and a 36 the b squared. Okay, so therefore a is the square root of 100, which is 10. B is the square root of 36, which is 6. Since the 100 is underneath the x's, then the ellipse is going to be longer in the x direction. So it's going to be longer in the horizontal direction. And that's all we need right now to graph it, and then we'll deal with the foci later. Okay, so we're centered at 0, 0. I'm going to go left and right 10. I'm going to go up and down 6. We've got the endpoints of our axes. And then just draw your best looking, oval looking ellipse. Sometimes what I do is I kind of just draw a sketch of the curve it's going to make at the points. And that way it looks more elliptical, not so flat. That's one of our, when we first start learning ellipses, drawing them are kind of hard. Okay, something like that. Okay, let's solve for the foci. So we're going to use the formula c equals a squared minus b squared. So c squared equals 100 minus 36. C squared equals 64. Oh, awesome. C is actually a nice number, so C is 8. So our foci, we're going to go left and right 8. I know I'm going to go left and right 8 because that's the longer direction of the ellipse. So we're going to end up at 8, 0 and negative 8, 0. So I could shortcut that and just write plus or minus 8, comma 0.